happens when it hits the fan?
Wait a second, isn't that not a fan?
What hit the fan? So here's what happens. This is the one time that we're allowed to say that there's an angle side-side. So every once in a while, we've always said that there's no ass in math, but in this case, there's a little bit of ass in math. So,
I'm kidding.
So what happens here in this, I like to go back to the idea of how it's worded as far as, side angle, side, all that kind of stuff, because it's easy to visualize when you're given information. So when we go back and talk about this whole idea of this side angle, because, we don't want to swear all day long, that's what it would look like. Whenever you have a side and its side opposite and another side, that's when you technically have side angle. You actually had a problem I think you had a couple of them like that yesterday where it just wasn't a big deal. It would force you to find angle B and things like that. And you've done that before. Well, what you didn't know was that was kind of the precursor to the possibility of, it hitting the fan, shall we say. Because what can happen if you have this case is that you can wind up with no triangles happening. And we saw that yesterday with the one question I showed you in class. And I think I had another one on here in the homework from last night. And then you could also run the risk of it possibly creating two separate triangles. So what we're going to do today is we're going to talk about what's called the ambiguous cases of the law of sines. Now, again, if you start talking about what this is going to look like, it's basically when you see this scenario, that's when you have to take a step back and think, okay, will this work? So if you've got your given side and the angle opposite, you're okay. So you saw this yesterday. If the given angle is obtuse and the side opposite it is larger than the other side given, you're fine. It's all good. Okay? It's all good. All good in the hood. So if you have let's say angle A in this case was, 120 degrees, side A is 17, and side B is 8. If that's what it looks like to start with, that's what that means. The angle's obtuse, the side opposite it is bigger than the other given side. If that happens, it should be just fine, okay? That's why I said you're all good in the hood. I'm something. If not, if the other side opposite happens to be smaller than that, is it possible? No, and that's what you saw yesterday also. What happens is, if the other side opposite if the side opposite the obtuse angle is smaller than another side, you can't have the triangle. And you guys caught that yesterday. When we had the one example in class and then we had the one problem on the homework sheet, or the homework itself. Was there two of them?
No, it was
I think there's just one.
But I missed out.
No solution, because I think it's like really hard. And I'm like, oh, this doesn't work. It's a no solution.
Yeah. You just give up and say,
No, I was like, I can't figure it out. So I'm like, oh, clearly there's no solution.
Clearly.
My calculator got one of about. So for like 10 minutes, I was like, why isn't this working?
Yeah. If you get into radian mode with some of this stuff, it'll get you some really weird values. Yeah. Yep. No, because what the calculator is doing is it's calculating values of sine between negative 90 and positive 90. So your obtuse angles become negative because it drops to the fourth quadrant. Give me a couple of weeks and you'll understand what I mean by that. Otherwise, you have all of this junk. Ew is right. Ew is right. There's all this craziness. Now, I know. What we've already talked about was the obtuse setup. Obtuse setup's pretty easy to not to have to worry about. It's either the side opposite you is either going to be bigger or smaller. If not, you're done. What happens when it's weird is when it's acute. Now, don't worry all about this. What happens here is, oops, let's go ahead and send this to the back, it'll be easier. What happens here is that if you worry so much more about the idea that what they write in here on the note stuff is that this angle A is your given angle. Little a is the side opposite, little b is the other given side. That's all this means, okay? That's what all this whole chart means. Excuse me. So what you're able to do when you're worried about it being a cube, and I'm going to show you a trick here. Don't write all of this out. It's a pain. It's in the book. You can look at it, read it to your little heart's content, or you can follow this simple step. Okay? What happens here is that if you go through your law of sines, and this would be my example of A being a cube. If A is a cube, and you have the side-side angle case, you have to check something. And what you check is, well, you set up your law of sines like you would normally. First thing we do is draw a picture. Okay. A is a cube. This is that side-side angle case where it's forcing you to find an angle first. Which angle is this forcing you to find? B. Okay. So we know that we have to find angle B to start with. A is a cube, and then you have to do this little trick after you find angle B. Oh, I'm sorry. I put it by B. My bad. Thank you. So we're trying to find angle C. What up? Yes. I think you rolled your eyes at me without rolling your eyes. That felt really bad.
Wait a second. Mr. Murphy.
What?
Aren't you trying to find angle B?
No, I was given side. I accidentally put the C value here as opposed instead of across from C. Yes, sir.
Your mistake made me think of a question. If we do that on a test where like it says C side C and we accidentally put it on side B,
I'll figure it out.
Okay.
I'm not worried about that. That'll happen. But that's the idea of labeling. As long as you label stuff through it, and I can just look what you did with your diagram, and I'll figure it out.
Wait, you're
That's
not
not
trying to
big.
find
So
the
you won't
angle
take
that's
out-
in between the two sides?
You're thinking law of cosines. No. Right now we're using law of sines with A and little a, and I'm given side C, so I'm having to figure out angle C.
Oh.
Okay. I accidentally put it in B's position to start with. That was just a mistake. Okay. So we write out. We have what sine of C is to 11. Yesterday when you did stuff like this was the quick case where all you had to do is multiply the other side by 11, right? So your answer is going to be 11 sine 20 over 10 is the sine of C. So we go to our calculator. And I get 0.376.
And you take the inverse.
Take the inverse sine of that. Make sure you're in degree mode. And you get that angle. 22.10 if I go 2 decimal places, okay? So angle C here's what we do. And this is the trick that I'm going to show you guys that'll work each time that you have law of sines, which with the possibility of when you're given your first angle as a cube. What I want you guys to do, after you find that next angle, always check and find its supplement. What I'm doing here is I'm going to find the supplementary angle to 22.1. What I'm doing here, when I subtract that out, you get, I wrote it down right here, 157.9. That's the supplement to angle C. Okay. What I do then is I'm checking, I'm going to call this C prime. What I'm doing then is that I go back to my original given angle. My original given angle was angle A. Angle A told me that it was how much? 20. Which means there's two possible angles then B could be. What happens here is by checking for the supplement of the first angle, when you check for the supplement of the first angle, if you put it back with the original given angle, this is your given angle A, if there's degrees left over to create a triangle, that means you could have two triangles. That means you wind up with two possible triangles for this case. A, B, C, we had 20. This was, what was it, 10? This was 11. And then the other one, what's happening here is that you're seeing that by the possibility that since C, when we first found it, was acute, we check its supplement, we got 157.9. If I added that to my original angle A, that means there's degrees left over for B. So it's allowing me to find angle B as two different positions. This is what we call the ambiguous case for the law of sines. It's weird. It's kind of murky. It's kind of weird.
Wouldn't that just mean that you messed up?
Nope. No, what happens then is that C could either be 22.1, or this was 20, or it could have been 157.9. Because this still works out to be 11, this still works out to be 10. Angle B then can be two different angles. So you wind up with a secondary triangle. Because you can bounce it and have room left over for us. All right, I shouldn't use the term bounce it yet because I haven't shown you what that means. You can use the supplementary angles to see that you wind up with an ambiguous, what's called an ambiguous case in the law of sines. This is a shortcut method that works, that I've been showing students for the past few years, as opposed to trying to get you guys to memorize all that junk. Because it's stupid. Knowing that if you can find a supplementary angle, which I know you guys can, and I know you guys can all subtract and add, you can do it this way. Yes, Jack?
I don't get like what that's for though. Like we didn't find anything like, not like new, but we didn't like do anything.
What happens here, and I'll show this. I'll show another full example here. Is when you have side angle with the law of sines. When you have side angle law of sines, if given angle is obtuse, all you do is check if opposite side is bigger than the other.
So because if you go back to the problem, because both angles are bigger than 20, it means you can have.
Yeah, what's happening? Yeah, because what's happening is that if this becomes 22.1, this becomes the medium angle with the medium side, which means 22 and as 40 was it 44.1, which means this is 136.9. No, 135.9. It could be 135.9 and then this side is bigger, which is okay. Or when I bounce it over to here, this side will be smaller and this will be a smaller side. So it gives you the plausibility of having two different side lengths with the biggest angle, biggest side still working.
Well, what's like the force? Like, why would you find them? Why do you need to find them?
What do you mean?
Like when we were doing this, yesterday we were finding.
Yeah, yesterday everything was setting up that it was always going to be one triangle. Today you're going to see the possibility that you could get two triangles, and all you have to do is check a supplement. Okay.
Well, yesterday.
Why to solve a triangle? To solve the triangle.
Yeah.
To find the area.
Oh, we're just solving for all the missing parts. That's all we're doing. We're solving for all the missing side lengths. And what's happening is that when you have, like I was saying, when you have an acute angle, you always have to check your second angle supplement to see if second triangle is possible. That's what's happening. Okay,
What do you do with the 177.9?
I'm going to show you. I haven't gotten that far yet. Okay? What's happening is that with that 177.9, that means those two angles that I have right now, A and C, that's what the sum of those two angles is, the 177.9. I subtract from 180, that gives me angle B. And then I use law of sines to find the opposite side. That's what I'm saying. If I go back to the 20 and the 22.1, I subtract those two from 180, that gives me my angle B. I use law of sines and I have a different side length B. What's happening here is that when you have an acute angle in the side-side angle case, you run the risk of possibly having a second triangle that could occur. Okay, that's what happens. That's why we don't talk about side-side angle in geometry. When you did proofs, I don't remember, I know I didn't do this in class, but did you guys do a thing on the computer where you try to create congruent triangles with, like there were little red and blue triangles and angles and stuff like that? I don't remember if Seth still does that or not. Bless you. Because in that setup, you can do the side-side angle and make it work, okay? Let me do an example where it works you through every single part of what happens, okay? Let's look at this. I'm going to walk you through the entire scenario of a side-side angle ambiguous case where, I'll give you a little hint, you will have a second triangle in this one.
What?
I know, okay? So, in this case, we have angle A, and side B. I'm given angle A and side opposite. Is angle A acute?
Yeah.
Yeah. All right, so that in back of your mind, remember, okay, that means I gotta check angle B to see if there's leftover angles to make two triangles. So we start with the law of sines. So we have sine of A is to 155, sine of B is to the 160. So I'm just gonna put the 160 over here right away because I know I'm gonna have to do it anyway. Okay. So I find angle B. 160 sine 70 divided by 155 gives me some crummy decimal. Use the inverse function to find the angle. My angle is 75.93. So I have angle B, 75.93. I go to my triangle, put it in. Right away, I'm going to see in angle B, what is the supplement of 75.93? If I subtract it from 180. If I subtract 75 from 180, I get 104.07. That's the supplement of angle B, so I'm going to call that B prime. And then exactly, I go back to my original angle. My original angle was 70. That's my original angle A. That gives me 174.07. Are there enough degrees left in that to get to 180? Or am I beyond 180? That means, since there's leftover angle measures, I can make two triangles. So I'm going to have an angle C here, and then I'm going to have a second triangle with 70 for A, a B prime at 104.07, a C prime for angle C, because these two angles will be different because they're two different triangles. That's what happens with this ambiguous case. All you have to do is check the supplement of the first angle that you find. If you add that to the original angle, it's less than 180, you have two triangles. If it's more than 180, you don't. You have one triangle. That's all it is. It seems, I open my watch up. It seems really, really weird, but all you have to do in order to check this is look at a supplementary angle. Okay? Reasons that this happened, we'll get more involved when you start looking at when I'm saying bouncing quadrants and stuff like that. When we get into the actual unit circle about why certain values occur, that's why we do that. The only reason I don't go with the unit circle yet, because that goes away from using any calculator stuff, and I want to do all the calculator stuff first. So I figured law of sines, law of cosines, a lot of button pressing, a little bit easier to talk about it now. Yeah.
So like once you get there, you just solve for everything else. Like
Yep.
the triangles?
Yep, then you have two triangles. It's like your one problem turned into two. Okay. Yeah, yeah. So now that I know what I have here, if I add these two together, I get what, and then I subtract it from 1/8. I'm sorry, subtract. What do you have?
When we find the second, oh wait, we have to find the length of the.
Yes, that's what Kathleen was just saying too. What happens here is we'll go back to the original triangle that we had for regular C and little c here. And when I do that, we take 180, subtract out the, what is it, 145.93. What are you left with for that angle? What is that, 3407? So this angle here is 3407. So I go back and I use law of sines again for that one.
Where'd you get 34?
How many degrees are in a triangle?
180.
Okay.
Oh,
subtract.
okay.
Alright. So I do a quick law of sines for up here. Sine of 70 is to 155. Sine of 3407 gives me little c. So 155 sine 3407, 155 sine 3407 divided by sine of 70. That gives me little c at 92.4. Okay. $92.04 for that. Does the largest angle have the largest side length in my first triangle? Yep. Medium angle, medium side, small angle, small side. All good there.
It's just 4 now.
It's just
Oh, just 4? Thanks. Still, we're okay. All right. And then I do it again down at the bottom here in the secondary triangle. We still have the 155. This is still 160. So I use the, what do we have for C prime here? Take 180 minus 174.07, and that'll give us, what did we say it was? 593. That's our C prime. And what we're doing is finding little c prime. So you have a sine, again, of your given, 70, 155.
What was the first C?
The first C, 30, the big C,
Yeah.
3407. Then let's do little c. So 155 sine 5.3 divided by sine 70. And little c is 1696. And again, notice big angle, big side. Medium angle, medium side. Small angle, small side. Your law of sine problem just becomes two problems. That's all it does. And all you have to do is check to see if the supplementary angle to the first angle found, added the first angle you had given, if there's enough left over to make it 180. That's what you're doing. It looks horrendous if you start reading through all the different steps that you have to do, like in the book. But if you just remember checking. Oh, I forgot to put the 3 in. You're right. Guys, I didn't type in my answer. I accidentally typed 5.9. I forgot to put 5.93. So what was yours? 1704. Does that sound better for what you guys got?
Yeah.
Sorry about that. Okay. So it looks really, really weird, but all you have to worry about is checking to see if that angle bounces as well. All right, if you have a supplementary angle, that'll work. Okay.
That's a lot of work.
All right. It is, but that's what you're looking at. Okay. Let me show you another one.
Don't be rude.
7 plus 5.93 is 180.
Let's try this one.
Your attitude.
That's not me.
Okay.
Do the mirror.
So if I try this one, I have angle A is 18 degrees, little a is 16, little c is 10. Notice this is again setting you up as that side-side angle. Or if you want, here's your angled side-side. Sorry. Did you forget to laugh? Which angle is this forcing you to find first? C. I labeled it correctly this time, right?
Yes. I think.
So we have the sine of 18 is to 16. So the sine of C is to 10. And we're okay that all you have to do is multiply the other side by 10? Okay. So we have 10 sine 18 over 16 is the sine of C. Second sine of my answer. And I get 11.14. Are we okay with that? Okay. My original angle was acute, correct? That means I have to take a second and check angle C's supplement. So when we check angle C's supplement, I take 180, subtract the 11.11 or 14, and you get, what is that, 168.86. That would be C prime. To that, what do I add? 18. I add original angle A. Oh, it's bigger than. So am I going to have two triangles? No.
186.
I only have one. Math is hard. In this case, right away, that the supplementary angle, if I add it back to angle A, is bigger than 180, which means there won't have to be two triangles. There is only one triangle. That's how you check it. If it wound up being less than 180, then you write it out as two separate triangles.
What if it is?
I don't know. I don't know. I never saw it. I honestly don't know.
There's a thing in the book.
If it equals 180, it's probably a right triangle. I think that's what it is. If it equals 180, I think it's a right triangle. No, if it equals A, it might. I don't know. Sure. So, did that make sense in what you have to do here? All you're doing is you're setting up loss lines like you did last year, you did yesterday, which wasn't anything crazy. But once you have once you double check to see if you have that that supplementary angle that'll work, that's all you're looking for. Will that supplementary angle work? If it does, you make the second picture. If it doesn't, just do it once. It's a lot easier to do it this way than it is the way the book shows. Okay? We all right? I'm gonna get you. Let's do same sections. This is what, 804, page 804. We'll do 30 through 34. And then 57 and 58. Okay? Check your supplements. Not the dietary ones. You don't get this kind of humor in other classes, do you?
You should be
My children would go hungry. What's it supposed to be funny? What's that?
What's all this funny?
Monkey. All right.
It's just his voice that gets me.
Yeah, same session.